Welcome to AWS Mastery Labs, turning AWS chaos into clarity with bite-sized tutorials, hands-on labs, and exam-smashing tips. In this video, we'll introduce you to Amazon CloudWatch, a powerful monitoring and observability service from AWS. You'll learn what CloudWatch is, why it's important, and how it helps you monitor your AWS resources and applications in real time. We'll cover the basics like metrics, logs, dashboards, and alarms, and show you how CloudWatch can help you keep your systems healthy, troubleshoot issues faster, and stay compliant with operational best practices. Let's get started. Let us explore how CloudWatch serves as a centralized platform for monitoring everything from infrastructure resources like EC2 instances and Lambda functions to application performance and custom metrics, all in one place. CloudWatch is more than just a metrics dashboard. It's an observability powerhouse that collects and tracks metrics, logs, and events. It aggregates this data in a multi-dimensional format, allowing you to slice and filter your operational data in meaningful ways, making it easier to identify trends, correlations, and outliers. One of the core strengths of CloudWatch is its ability to monitor your environment in real time. Whether it's a spike in CPU utilization or a sudden surge in latency, CloudWatch captures these changes as they happen, giving you the agility to respond quickly and maintain performance. CloudWatch also goes a step further by providing actionable insights. It can automatically detect anomalies, help you set up alarms, and even trigger automated responses, all of which help optimize your applications and keep your infrastructure running smoothly. With native integration to over 80 AWS services, CloudWatch can automatically start collecting metrics without requiring extra setup, saving you time and ensuring coverage across your environment. While it's a regional service, CloudWatch offers global data aggregation, so you can consolidate monitoring data from multiple regions into a single view, ideal for distributed applications. And finally, CloudWatch is built to scale automatically with your infrastructure. Whether you're running a single EC2 instance or managing a complex microservices architecture, you won't need to provision or manage any monitoring infrastructure. CloudWatch grows with you. Now, let's take a closer look at the core components of Amazon CloudWatch, each designed to help you monitor, visualize, and respond to what's happening in your AWS environment. We'll start with CloudWatch metrics. These are time series data points that represents like CPU usage, disk I/O, memory utilization, and more. Metrics are collected at regular intervals and give you quantitative insight into how your resources are performing over time. You can view metrics for AWS services out of the box or publish your own custom metrics. Next, we have CloudWatch logs, a centralized log management system. Whether it's application logs, system logs, or custom log data from on-premises or cloud resources, CloudWatch Logs helps you store, search, and analyze all of it from a single interface. This makes troubleshooting and auditing much faster and more efficient. Then there's CloudWatch Events, which has evolved into Amazon Event Bridge. This component allows for event-driven monitoring by capturing changes in your environment in real time, such as the launch of a new EC2 instance or a change to an S3 bucket, and routing those events to trigger responses like Lambda functions or notifications. CloudWatch alarms are crucial for staying proactive. You can define thresholds on metrics, and when those thresholds are crossed, whether too high or too low, CloudWatch can trigger automated actions or notify you immediately, helping you respond before small issues become big problems. For visibility, CloudWatch dashboards provide a fully customizable way to visualize your metrics and logs. You can build charts, graphs, and gauges to track performance indicators across your entire AWS environment, all from one screen. To dig deeper, CloudWatch Insights offers powerful analytics tools. For example, Log Insights allows you to query logs with a simple query language, helping you uncover trends or anomalies quickly. Other specialized tools like Container Insights and Lambda Insights give you deep visibility into containerized workloads and serverless functions. CloudWatch automatically collects standard metrics from more than 80 AWS services. These include common performance indicators like CPU utilization, disk reads and writes, network throughput, and other service-specific metrics. But CloudWatch doesn't stop at standard metrics. You can also publish your own custom metrics to track things specific to your applications, like the number of users logged in, items in a shopping cart, or database query times. This is done through the Put Metric Data API, allowing you to send data directly to CloudWatch from your applications or scripts. CloudWatch supports multiple metric resolution levels to match your monitoring needs. By default, metrics are stored at a 1-minute resolution, which works for most use cases. But for more fine-grained tracking, like monitoring high-frequency transactions or low-latency systems, you can use detailed monitoring at a 1-second resolution. This gives you a closer look at short-term spikes or drops in performance. With metric math, you can create derived metrics by performing calculations on existing data, like averaging memory usage across instances, calculating the error rate percentage, or tracking the difference between request and response counts. These calculated metrics don't consume storage, but they give you powerful analytical capabilities on the fly. To keep your metrics organized and searchable, CloudWatch uses dimensions, name-value pairs like instance ID, auto-scaling group name, or instance type. These dimensions let you filter, group, and compare metrics with more precision, helping you drill down into specific resources or patterns. CloudWatch metrics have a 15-month retention period with varying levels of granularity. Recent data is stored at full resolution for detailed analysis, while older data is automatically rolled up to save space, allowing you to analyze trends over time without managing storage. Finally, CloudWatch also supports metric streams, which allow you to continuously export your metrics to external tools like Datadog, Dynatrace, or New Relic in near real time. This is useful if you're already invested in other observability platforms, but still want to use CloudWatch for collection and transport. CloudWatch Logs allows you to collect, store, and analyze logs from a wide range of sources. Whether it's EC2 instances, Lambda functions, or containers, logs can be collected using the CloudWatch agent or through native service integrations. This gives you consistent log visibility across your entire AWS environment without having to manage multiple tools. To keep things organized, CloudWatch uses log groups, which act as containers for your log streams. Each log group can have its own retention settings, encryption policies, and access controls. This makes it easy to manage different applications, teams, or environments with tailored configurations. One of the most powerful features is real-time log processing using subscription filters. These filters can automatically forward matching log events to services like AWS Lambda, Kinesis data streams, or data firehosts. This enables near-instant processing for tasks like alerting, analytics, or feeding logs into external systems. CloudWatch also supports metric filters, which let you extract meaningful values from your logs, like error counts, latency figures, or custom application metrics. These values are then turned into CloudWatch metrics, making it easy to set up alarms and dashboards even from unstructured log data. For more advanced analysis, CloudWatch Logs Insights provides an interactive query language specifically designed for log analytics. You can run ad hoc queries to quickly identify issues, visualize patterns, or troubleshoot failures, all within a matter of seconds, even across large data sets. If you need to archive logs for the long term, CloudWatch makes it easy to export log data to Amazon S3. This is especially useful for compliance, auditing, or cost-effective storage of historical logs. And of course, if you're handling sensitive or regulated data, CloudWatch Logs supports encryption at rest using KMS. This ensures your log data is secured according to your organization's privacy and compliance requirements. CloudWatch alarms help you stay on top of your application and infrastructure health by notifying you when something goes wrong, or even before it does. The most basic type is a threshold-based alarm. This lets you define a static value, and CloudWatch will trigger an alarm when a metric exceeds or falls below that value. For example, you might set an alarm if CPU usage goes above 80% or if disk space falls below a safe threshold. For more intelligent detection, CloudWatch supports anomaly detection alarms, which use machine learning models to automatically learn what normal looks like based on historical data. You can also create metric math alarms. These are based on calculations or combinations of existing metrics, like averaging memory usage across multiple instances or calculating a success rate as a percentage of two other metrics. This is perfect for building custom health indicators tailored to your application. To reduce alarm noise, CloudWatch allows you to build composite alarms using logical operators like and or. This means you can wait until multiple conditions are met before triggering an alert, helping you avoid false positives and focus only on real issues. Alarms can exist in one of three states. Okay, when everything is within expected limits. Alarm, when thresholds are breached. Insufficient data, when CloudWatch doesn't have enough data to determine the current state. You can also fine-tune how sensitive your alarms are by adjusting evaluation periods and data points to alarm. For instance, you might want to alarm only if 3 out of the last 5 data points exceed the threshold, helping to balance responsiveness with stability. Finally, alarms integrate seamlessly with Amazon SNS or simple notification service. This allows you to send notifications via email, SMS, mobile push, or even webhooks to alert your teams or trigger automated remediation steps. One of the most user-friendly and visual features of Amazon CloudWatch is the CloudWatch dashboards. These dashboards provide a customizable interface that allows you to visualize key metrics and logs in one centralized place. With a simple drag-and-drop interface, you can build dashboards that suit your specific monitoring needs, whether you're tracking application health, infrastructure performance, or specific operational KPIs. This allows teams to quickly interpret what's happening across the system at a glance. CloudWatch supports a wide variety of widget types to help you visualize your data the right way. These include line and stacked graphs, single number displays, gauges, alarm states, text blocks, and more, each offering a different lens through which to monitor performance or issues. One of the most powerful features is the ability to display metrics across multiple accounts and regions. This means you can monitor your entire AWS environment globally from a single dashboard. This is especially helpful for organizations with distributed workloads or multi-account strategies. Dashboards are also live and dynamic with auto-refresh capabilities. You can view your most current data in real time without having to reload or navigate away, which is essential when troubleshooting issues or during live incident response. When it comes to collaboration, sharing and access control is built in. You can share dashboards with teammates or different departments using IAM-based permissions, keeping your operational views consistent yet secure. Finally, CloudWatch dashboards support drill-down actions. So when you spot a spike or drop in a graph, you can click directly into the associated metric or log data to perform a deeper investigation. This smooth transition from overview to detail helps accelerate root cause analysis. To get deeper insights into your systems, especially those running on Amazon EC2 or even on-premises servers, you can use the CloudWatch agent, a powerful tool that extends the default monitoring capabilities of CloudWatch. By default, CloudWatch provides basic metrics like CPU utilization from EC2 instances. But with the CloudWatch agent, you can collect a broader range of system-level metrics, such as memory usage, disk space, swap utilization, and even process-level performance data, things that aren't available out of the box. The CloudWatch agent is a unified solution that supports both metrics and logs collection. This means you don't have to install and manage multiple agents to gather different types of data. It simplifies deployment and streamlines your observability setup, saving time and reducing complexity. Configuration is also flexible and developer-friendly. The agent uses JSON configuration files, allowing you to specify exactly which metrics and logs you want to collect, how frequently to collect them, and where to send them, all without writing any code. The agent works across both Windows and Linux operating systems, which is ideal for hybrid or diverse environments. Whether you're monitoring legacy applications on Windows servers or modern microservices on Linux, you can maintain consistent and unified visibility across all your systems. In addition to basic system metrics, the CloudWatch agent supports integration with StatsD and Collecta protocols. This allows you to collect custom application metrics and leverage existing open-source monitoring tools that may already be part of your infrastructure. To make things scalable, The CloudWatch agent can be deployed across large fleets of instances using AWS Systems Manager. This enables centralized configuration and automated deployment, which is especially useful in dynamic or auto-scaling environments. When it comes to understanding what's really happening inside your applications and infrastructure, logs are invaluable. But searching through endless lines of log data can be overwhelming, and that's where CloudWatch Logs Insights comes in. CloudWatch Logs Insights is an interactive query and analysis service that helps you make sense of your log data quickly and efficiently. With this tool, you can write fast, SQL-like queries to explore your logs without any need for data preprocessing or complex pipeline setups. It uses a purpose-built query language designed specifically for log analysis. The syntax is intuitive and powerful, giving you exactly what you need to filter, parse, and extract insights from raw log messages, all in just a few lines of code. Whether you're filtering logs for error messages, calculating averages, or grouping data to find patterns, Logs Insights supports complex queries with filters, mathematical calculations, and aggregations. This allows you to zero in on the root cause of issues quickly, even in large volumes of data. You can use it for both real-time troubleshooting and historical analysis. One of the most useful features is the ability to visualize your query results. Logs Insights can turn your query output into time series graphs or tables, giving you immediate visual feedback to help spot trends, anomalies, or usage spikes. To improve consistency and save time, you can also save queries that you run frequently. This is perfect for recurring investigations or for teams that want to standardize their log analysis workflows across projects or environments. And finally, you're not limited to just one log group at a time. Logs Insights allows you to run queries across multiple log groups, enabling you to correlate logs from different services or applications in a single view. A huge time saver during complex investigations. As organizations adopt containerized architectures, monitoring becomes more complex, and that's where Amazon CloudWatch Container Insights comes in. This feature is designed specifically to provide automated observability for containerized applications and microservices running on services like Amazon ECS, Amazon EKS, Kubernetes on EC2, and AWS Fargate. With Container Insights, you get a multi-dimensional view of your entire container infrastructure. It automatically collects metrics at multiple levels, from the cluster level down to individual nodes, pods, and even containers. To help you hit the ground running, CloudWatch provides pre-built dashboards tailored for container environments. These dashboards visualize key metrics out of the box, so you can quickly identify issues, track resource usage, and understand workload behavior, without spending hours configuring charts or widgets. Container Insights is also tightly integrated with CloudWatch Logs, allowing you to correlate performance metrics with log data. This is especially powerful for troubleshooting. When a container slows down or fails, you can dive into the associated logs to pinpoint the cause. The platform collects a rich set of performance metrics, including CPU usage, memory consumption, disk I/O, and network traffic, giving you comprehensive visibility into how your containers are behaving under load. You can also configure CloudWatch alarms using these container-specific metrics. Whether you want to be alerted when a container exceeds its memory limits or when a pod restarts too often, you can set up thresholds that trigger notifications, helping you respond to problems quickly. And for even more advanced monitoring, Container Insights supports custom metrics collection using the CloudWatch agent. This means you can track application-specific metrics, like the number of processed requests or response times, all within your containerized workloads. Imagine being the first to know if your website or application goes down, even before your users notice. That's exactly what Amazon CloudWatch Synthetics helps you do. CloudWatch Synthetics uses Canary scripts, which are lightweight, automated tests that simulate user activity to monitor the availability and functionality of your web applications, APIs, and endpoints. These synthetic tests run at regular intervals to proactively detect issues before they impact real users. One of the key benefits of synthetics is the ability to run tests from multiple geographic locations using AWS regions around the world. This helps you understand performance and availability from your user's perspective, no matter where they are. To help you get started quickly, Synthetics offers a range of blueprint templates for common monitoring scenarios. Whether you need a simple URL check, an API endpoint test, or a multi-step UI workflow, these templates allow you to deploy canaries in just a few clicks. For more advanced needs, you can build custom canaries using Node.js or Python. This gives you full control over the behavior of your tests, ideal for complex validation logic, application-specific flows, or specialized business requirements. Synthetics can also capture screenshots and HAR files, which serve as visual and network-level evidence of what your application was doing at the time of test execution. This helps you verify visual behavior and troubleshoot front-end or loading issues with precision. And because it's tightly integrated with the broader CloudWatch ecosystem, Synthetics publishes metrics automatically that you can use to trigger CloudWatch alarms. If a test fails, if response time spikes, or if a page returns the wrong status code, you'll be instantly alerted. Finally, Synthetics provides detailed execution logs and step-by-step tracing, so you can pinpoint exactly where and when a problem occurred, reducing your mean time to resolution and boosting your application reliability. One of the most powerful aspects of Amazon CloudWatch is how seamlessly it integrates with other AWS services. Let's start with Amazon Event Bridge, which allows you to build event-driven workflows. You can respond to changes in your environment and automatically trigger Lambda functions, step functions workflows, or SNS notifications. It's an easy way to automate incident response and operations. Next, there's AWS X-Ray, which provides distributed tracing for applications. By combining CloudWatch metrics with X-Ray traces, you gain a complete picture of how individual requests are performing across microservices. This helps you isolate latency, identify bottlenecks, and diagnose errors deep within your stack. CloudWatch also plays a critical role in auto-scaling. By using CloudWatch metrics, like CPU utilization or custom application metrics, you can configure your auto-scaling groups to automatically increase or decrease capacity based on real-time performance, ensuring optimal efficiency and cost control. With AWS budgets, you can monitor your CloudWatch usage and broader AWS spending. This integration helps you stay on top of your cloud costs by sending alerts when you approach or exceed predefined budget thresholds. For governance and compliance, AWS Config can verify that essential CloudWatch resources, like alarms for high CPU or failed login attempts, are consistently in place across your infrastructure. This ensures your monitoring practices meet internal policies and regulatory requirements. When it comes to notifications, SNS and SQS can be used in tandem with CloudWatch alarms to route alerts via email, SMS, or push them into queues for downstream processing. This makes it easy to integrate alerting into ticketing systems, chat platforms, or incident management tools. And finally, IAM gives you fine-grained control over who can access or modify CloudWatch resources. By assigning specific permissions, you can enforce least privilege access across teams, ensuring that only authorized users can interact with dashboards, alarms, or metrics. As powerful as Amazon CloudWatch is, it's also important to understand how to use it cost-effectively. In this section, we'll explore how to manage and optimize your CloudWatch usage to keep your monitoring both effective and affordable. First, let's talk about the AWS free tier. CloudWatch includes a generous amount of free usage, such as basic metrics at 5-minute resolution, 10 custom metrics, 5 GB of log ingestion, and 3 dashboards with up to 50 metrics each. For many small or new workloads, this might be all you need. Next, be aware of the main cost drivers in CloudWatch. These include metric resolution, with higher granularity costing more, custom metrics, and the volume of logs ingested and stored. Logging everything at detailed resolution without a strategy can quickly lead to escalating bills. That's why it's essential to implement cost optimization strategies, especially for CloudWatch logs. Start by setting log retention policies to automatically delete logs after a certain time. Not every log needs to live forever. Set shorter retention for low-value logs. You can also filter out unnecessary log events at the source using subscription filters or application-level logging controls. Similarly, for metrics, avoid collecting at 1-second resolution unless absolutely necessary. By right-sizing the collection frequency, you can strike a balance between observability and cost. If you're using contributor insights, remember that analyzing high cardinality datasets like IP addresses or user IDs can become expensive. Optimize rules to focus on actionable insights and reduce overuse of high-volume dimensions. For proactive cost control, set up budget alerts specifically for CloudWatch spending. AWS budgets can notify you when usage or costs exceed your predefined thresholds, helping you avoid surprises. Finally, dive into AWS Cost Explorer to track and visualize your CloudWatch spending over time. You can break down costs by service, usage type, or time period, making it easier to identify trends and take corrective action. Start simple. Use the default metrics that AWS services provide out of the box. These include CPU utilization, network traffic, disk I/O, and more. Begin with these built-in metrics and expand incrementally as your understanding of the system evolves. Over time, you can introduce custom metrics tailored to your application needs. One of the most overlooked but critical steps is to implement a consistent naming convention. Standardize names for metrics, log groups, and alarms across your environment. A clear, predictable structure makes it easier to find, query, and manage your data, especially in large or multi-team setups. Next, design a multi-tier alarming strategy. Not every alarm needs to wake someone up in the middle of the night. Use severity levels, for example, informational, warning, and critical, and establish escalation paths to route alerts to the right people or systems based on urgency. For effective troubleshooting, correlate metrics with logs. If an alarm is triggered, being able to dive into the relevant logs in the same context helps pinpoint root causes much faster. Consider using infrastructure as code tools, like AWS CloudFormation or Terraform, to automate the deployment of your monitoring setup. This ensures consistency across environments and makes it easier to scale or replicate your configurations. Before setting thresholds, spend some time establishing baseline performance. What does normal look like for your applications? Understanding the steady-state behavior helps you configure more accurate and meaningful alarms. It's also a good idea to document your monitoring strategy and create runbooks, clearly defined procedures for handling different types of alerts. This minimizes guesswork during incidents and ensures smoother operations. And finally, make it a habit to regularly review and optimize your monitoring configuration. As your environment evolves, so should your monitoring. Remove outdated alarms, fine-tune thresholds, and adjust retention settings. Thank you for joining us in this video. If you haven't already, we'd love for you to subscribe to our channel to stay updated with our latest content. We look forward to sharing more insights with you in another video. Until then, keep exploring. And thank you for watching.